Hello everyone, and welcome to another video where we'll learn about some intermediate to advanced SQL injection techniques. We're using the TryHackMe platform, and the name of the machine or the room that we are in is SQHell. Yeah, so this is an intermediate difficulty machine, so the techniques are not straightforward. You need to have a bit of skill to be able to go through these challenges. So we have how many flags? We have 5 flags in total, and some of the flags have hints. So if you get stuck, you can come and actually go through some hints, and then you go back to the exploitation. I didn't know why they named this machine SQHell until I started. It can really feel like hell when you're trying to exploit some of the flags. Some of the vulnerabilities are really not straightforward to exploit, and you really feel like you're in hell. So I think that's why the machine was named SQHell. Yeah, we'll see about that in the challenges when we start. So as I said, this is medium level. It's not an easy level machine or easy difficulty machine. This is a medium difficulty machine, so we have to expect some very difficult challenges to go through. So the machine is already up and running. What we need to do, let's read some instructions which are going to be very critical in our exploitation process. So give the machine a minute to boot. So I think the machine has already started. So we have the IP address here. We can copy this IP address to our clipboard, and then these are other information that they want us to know. There are 5 flags which we were already aware of. So from flag 1 to 5 to find, but you have to defeat different SQL injection types. Yes, so different techniques or different types of SQL injections are thrown around in the web application. We have to find that out, and then we've been given some hints here, very useful hints. Unless displayed on the page, flags are stored in the flag table in the flag column. So they're telling us that all these flags that we are going to look for, they put them in a table called flag and then in a column called flag. All right, so if you are doing your select statement to get information from a database, you have to know that you are trying to access a table called flag and then a column called flag as well. So we'll see how we can use this hint, or this hint will come handy later on in the exploitation process. So I already copied the IP address, so I can just follow this link. I can open the link on the new tab, and then this is the application, or the vulnerable web application. It's like a blog. All right, so this is my blog, and then we have some functionalities. We have login and register, so you can either log in or register as a new user. And then we have some already existing blog post here. So we have first post and then second post, and both posts are made by admin. You can use this readme to actually see the whole blog. I think this is just part of the blog, but if you want to read more, you can use the readme to expand or open up the whole blog to have a read. And then we also have terms and conditions. So we'll see all this, and then I think we can start with poking around the application. So for the exploitation, we are not going to go according to the flags. We are just going to do them randomly. So we are not going to say flag 1, flag 2. So whichever flags that we try exploiting first, then when we get the flag, we go and submit it. So we can start. I think the easiest flag is flag 1, which I know is on the login page. So on the login page, what we're going to do is we're just going to throw in a basic SQL injection query here to bypass this login page. So it's like this is an authentication bypass kind of injection that we are going to do on this page. So we can say apostrophe or 1 is equal to 1, and then we comment the rest out. Let's see if this is correct. This should be able to log us in and bypass authentication. If you don't, okay, So invalid username or password. So this was not successful. Let's see. So maybe they want the password to we want us to enter something into the password field. Let's try that. That doesn't work as well. So we can still see why. Okay. Yeah, so we are already in the challenge. We are already having issues. So let's try to actually work on this together. What are we missing? Oh, 1 is equal to 1. Let's add another. Okay, so that last dash sign was what was preventing us from logging in. Okay, so we have our first flag here. So flag 1, we've got our flag 1. So you see how challenging, this is even the easiest flag, but at least you can see how we can actually debug some of our injection scripts when they are not working. So let's keep some notes, and then let's say in the notes we're just going to have flags, and then we have flag 1. All right, so this is our flag 1. Then we go back and hunt for the other flags. So we can go back to the home page and then see which flag we're gonna try to exploit next. I think we should go, let's see, if we go to read more, if we open read more, it has opened the whole post for us to read, but we can see that this is a parameter, ID parameter, which is bringing out the post. So if we change this one to ID1, so that's the post ID, so it's going to query for that particular post. So this is first post. If we change it to 2, it will be second post. So whatever you put here, we assume that it sends it straight to the database without actually sanitizing what is sent. So this is a potential injection point. So if we put 3, we don't have any post by the name 3. So we can leave it here and then try to use our union select statement to see if we can get other. We can throw in our own query. So union select 1. Okay. So it tells us that the number of columns are different. So this means that our query is correct, just that we are not getting the right columns. So we try columns 2. This is still giving us the same error. So we try columns 3. Okay. So we still have the same. Let's see columns 4. All right. So it means we have 4 columns in that particular table. All right, and then the vulnerable columns are column 2 and column 3. All right, so we can just try to inject whatever we want to inject in the vulnerable column, which is the column 2, and then we're trying to get data from the flag column. All right, because we were told that all the flags are stored in the flag table and the flag column. All right, so in this case we are not going to brute force the table name or the column names. We already know that the table is flag and then the column is flag. So that's what we're going to do here. So we are going to select flag, that is the column name, from the table name, which is also flag. Let's see if this one will give us something. Yes, so we are able to get flag 5. So as I said, we're not going to go through this from flag 1 to flag 2, flag 3. We are just going to go after the flags as and when we are exploiting or exploring the application. So we have flag 5. Yeah, so we can store flag 5 here. So we still have 3 more flags to go. We have 2 flags down, 3 more flags to go. So let's see what is going to be our next flag. Okay, so let's go back to home. That is our web application, and then the next flag we're going to look out for is we can go to the admin. So to see if you hover on the admin and you look at the status bar. So let's just select admin and see what is in admin. So if you select the admin, you're able to see the user. So it takes us to the user's page and then the user ID. So user ID 1 is admin. All right, let's see if you have another user with a different ID. So we try user ID 2. We don't have any user with ID 2. So we go back to our user with ID 1. So we don't have for ID 2. So we can use this to try and see if it's sending the user ID directly to the database. That can also be vulnerable to our union injection attack. So union select 1. Let's see if this will bring us some information. So we don't have any information here. So we continue with 2. We don't get anything. We go to 3. Okay, so when we go to 3, we can see that it brought up some posts for the user ID 1. Okay, so what it tells us is that we have 3 columns in this particular case. So we have 3 columns, but there's something interesting here. If we change, let's change it. So we don't see 3 here, so we see 1 and 2. So let's try to change 2 to something else. Let's change 2 to 5 and see what happens. So you see that when we change 2 to 5, so this particular column is being updated. So it's 5. So let's change it back to 2 and see what we get. We still have 2 here. So let's change 1, 2 to something different and see. So if you change 1 to 5, we can see that the post has disappeared. So it means there's something special going on in the 1 position. So what tells us is that there may be a nested query. Okay, so this particular value is always supposed to be 1 for you to get this particular information. So it queried the database and then it queries another information, and then the result is supposed to be 1. That's what it's looking out for. All right, so this is a technique in databases or in SQL, what we call SQL Inception. So SQL Inception is like a nested SQL query. All right, so if we go back and check, so this particular attack or technique was very, very challenging. So I think that should be the flag 4. If you look at the hint, well, dreams, they feel real while we are in them, right? So this is like a movie called Inception. So if you try to find out what this particular thing means, you go and Google it, to send you to a movie called Inception. And then when you try to find out what Inception is relative to SQL, then you learn about SQL injection. SQL Inception, that talks about nested SQL queries. So we go back to our case. So here it means the 1, we can put a nested query inside a particular place. So we leave it as 1, and then we can use a union select statement also, and then we try to just brute force the columns. So if we put 1, there's no information here, so we don't have 1 column for that particular first query. We put 2, we don't have 2 for that. We don't have 2 columns for that second query. We put 3, it doesn't show anything. Let's put 4. So if we put 4, you can see that it has brought back some information. So it means we have 4 columns for the first query, and then it's bringing back this information because we have 2 queries running. So the first query will select with an ID of 1, and then we'll union select it with our own query. All right, so because 1 is what it's expecting, that's why it brought up the first and the second post. But if we put something apart from 1, it's just going to display our query. So if you put 2 here, you can see that the information for the post got disappeared or it vanished, and it's just left with the result for our query. All right, so we can see that from our select statement, the vulnerable column is 2. So it means if we go and we can extract our data or information from this particular column. So we want the flag, and then from the flag table, let's see what happens. Yes, so we are able to get the flag from the flag table over here. So this is our 4th flag. So we have 3 down, 2 more to go. So the next 2 flags, or what we're going to do is actually, in our previous SQL injection video series that was to do with the introductory part of SQL injection, I tried to use the manual exploitation techniques, all right, so that you can understand the underlying workings of SQL injections. But we have tools that we can actually use to do this exploitation. One of the tools is called SQL Map. So I didn't want to throw SQL Map in the beginning, but it's something that we can use. So here I'll try to demonstrate how we can use SQL Map, at the end of the video. Yeah, and then I also introduce some automation. So it's very important if you are into cybersecurity or IT, you learn how to use some programming language or scripting languages to do automation. So I will show how we can automate some of the processes here, especially if the task is repetitive. So we should be able to just script it out and then let it do its thing. And with that, it will save you time and effort so that you can focus on other tasks. All right. So we are now looking for which flags we have. So we have flag 2 and 3. So that's what we have to look for. So for flag 2, let's see what. Okay, I think we should go for flag 3 first. Yeah, let's go for flag 3. So we've not actually explored this register functionality. So we come to the register functionality. We're trying to register a new account, and then if we try to input anything here, we are getting some feedback, so some information. Username is available, so it means we can be able to register with this particular username, ADMK. This is just a keyboard slam I'm putting here. All right, so it's like something is happening in the background, something is happening in the back end. All right, because it's telling us that even though we've not submitted the request, but it's telling us that the username is available. So it means whilst we are having key downs, we are pressing the keys, it's checking something is happening in the background, it's checking the database to see whether the particular user already exists or not. So if you try to put admin, you see that username is already taken. All right, so this tells us that something is actually happening in the background. So if admin is already taken, we cannot register as admin. So this is kind of like a Boolean based SQL injection. So it means if you have a user which already exists, you are going to have this particular feedback, and then if you have a user that doesn't exist, you get this feedback. So we have 2 feedbacks that we're going to get. So it's either username is available or username is already taken. So this is kind of a Boolean based SQL injection type. All right, so let's see how we can exploit this. Also, we can actually see what is happening. So if we try to inspect this particular the elements for this particular page, we come down to here, we have events, and if we look here, we can see the code which is actually doing this particular check. So if we copy the code out and come and paste it here, we can see what happens. So this is like a function that checks for the user status. All right, so if you know about jQuery, so this is like a jQuery that does that, and then you'll be able to see a particular route here. So register user check. So this is like an API endpoint, and then the username get passed here. So this is, it concatenates the username. So whatever you put as a username, it sends it to the API, and then the API does the check. All right, so we can actually try to access this particular endpoint ourselves and see what is there. So let's see. I'm just gonna open another wrong page, but this time around, oh come on. So this time around we're trying to access the endpoints. So all right, so it's true because I didn't put anything. So let's say admin. So admin is false because admin is already there, so it's false. So anytime we put a username that already exists, we are going to get false, and then if we put a username that doesn't exist, we are going to get true. All right, so that's the API endpoint. That's what it's doing. So we can come back to our application, and then we can try to use our union select statement, and we put one here. All right, so it doesn't work, and we try other columns. We put 2, it doesn't work. It's still telling us that username is available, so that doesn't work. We put 3. Okay, so when we put 3, it's like username is already taken. So username already taken, so it's like we've been able to get a positive response. All right, so what it tells us is that this particular how do you call it, table we are trying to access has 3 columns. All right, so we can now, because we know the table, we can, and we also know we know the table has 3 columns, and we know the table name is called flag. So select 1, 2, 3 from flag, where flag, like, so we're trying to find a flag. Okay, so how we're going to try to find a flag is to find it character by character. All right, so we'll put it into something like this. All right, so it means if you get username already exists, it means our query here is correct. So if we try to put a, like we're trying to brute force the flag, we say the flag starts with an A, it doesn't. So if you say the flag starts with a B, it doesn't. C, it doesn't. But when we go to T, see that we have username already taken. So anytime we see username already taken, it means whatever flag we have here is correct. So it means the flag starts with T, and then the percentage sign is just like a wildcard. So it means T and then whatever comes next or whatever comes after. So if we put TA, it doesn't start with TA. TB, it doesn't start with TB. If we go to TH, it starts with TH. THM, it starts with THM. I know how the flag structure looks like. So this is how the flag structure looks like. So something. So THM for TryHackMe, and then flag, the flag number. All right. So we can go back here. So THM flag, but we don't know the flag number. We know we have flag, we are looking for flag 3 and 2 here. So let's put flag 2 and see. So it's not flag 2, that's why it has come back with username already available. But if we put flag 3, you see that. So we have flag 3 and then column, and then we are going to be able to, we are supposed to put all these characters one by one. You're supposed to brute force the characters one by one, one after the one. You see, so this can be very, very tedious. So that's why we should be able to automate something like this. So in order not to go through the pain of trying to brute force the whole flag, we can see how the length of the flag. Let's see how long the flag is. Let's see. So the flag, we can echo this flag. We're just trying to find how long the flag is, and then we can pipe this to WC, which is word count. Let's see how long this flag is. So the flag is 32. So we have 32. The flag is 32 in length, 32 characters. We don't have that time and luxury to do that brute force individual character at a time. So we need to automate the process, and I've already written an automation script which you can get from my GitHub. So let's say I'm just going to access my GitHub. My GitHub name is SQHell. Let's reject this. So I think this should be it. Let's go in here and see if that is my GitHub page. Not this. Okay, I'm trying to search for my own GitHub. I can't find it. Okay, let me add another name. Let's see. Okay, so yeah, so this is the actual GitHub repo. So I just go to my repositories, and then you can see some scripts here. So SQHell exploit. So this is what we are looking for. And then we're after flag 3. So I have script for flag 2 and 3, but we're going to do flag 3 first. So let's open flag 3. So this is the script. It's kind of like it's not that much, very straightforward, simple, and it's written in Python. Anyway, so I'll just go back to so I'll need to save this. Let's see, vim, and then let's say flag2.py, and let's put this here. All right, so we have flag2.py. We can cut flag2.py, and then this is the information we have in flag2.py. So what we need to do is just to run it, Python flag2.py. That's it. And then the flag, so the script will ask us to enter the target IP. So we just need to bring the IP here. So we have our IP here. This is the target IP. We go back to our our script, and then we enter that and wait for the magic to happen. So it started brute forcing the flag character by character. So the exploitation process is ongoing. So yeah, this is for flag 3. Just wait for all the characters to come back, and then we should have our flag. Okay, so that's it. So instead of us to try character by character as we're trying to do, let me just put this flag. This is flag 3, so it comes before flag 4. Yeah. So instead of us to do it manually as we're trying to do here, okay, the script has done it in less than a minute. Let me see how long it took. It took 54 seconds. So it took 54 seconds to get a flag back for us. So that's it. So we have flag 3 done. So the last flag is flag 4. Sorry, flag 2. All right. So for flag 2, it's kind of a bit tricky. So if you go back to the main page and you look at flag 2, so flag 2, there's a hint here for you. So the hint is make sure you read the terms and conditions. So if you don't read the terms and conditions, you may actually find it difficult to find clues as to what you do here to get the flag. So we can also come back here and read the terms and conditions, and then these are the 3 terms and conditions that they have for us. So the first one is we own the soul of any visitor or visitors. We can't be blamed for any security breaches. They are trying to issue disclaimers here. We log your IP address for analytics purposes. We don't know whether that's true, whether they really is only for analytics. We don't know. Well, we can find out. Yeah. So the last condition here is very important. They are telling us that they log our IPs. All right. So with a little bit of research before, if you want to log IPs of visitors making requests to your server or application, there is a header you can add which is called X forwarded for. All right, so this header will be able to grab the IP address of the originating request. Okay, if you don't use the IP, if you don't use the X forwarded for, mostly what gets logged, what IP address gets logged is mostly maybe a CDN. All right, because your request probably get bounced between CDNs before it reaches the destination, so the server may not be able to get the original IP address for the source. So the X forwarded for is what is mostly used. All right, so we're also going to use this particular X forwarded for header to see if we can get how do you call it, if we can get the flag. All right, so what happens is that we assume that because it's saying it's going to log our IP address, so whatever we put in that particular X forwarded for, it just takes it, it doesn't do anything to it, and then it try to add that to the database or try to set that from the database. All right, so that is what we are going to do. So we are also going to inject something into that particular X forwarded for header before we send our request. All right, so we can do this in several ways. So the first one is to do it manually. All right, so the manual, to do it manually, so the manual injection, let's see how we can do that manual injection. So the manual injection, we can just issue a curl command. So we're trying to make a curl request to our web app. So let's copy this. All right, so we're trying to make a curl request to the web app, but we don't stop here. So to do that, we try to add a header. So the header is going to be called X forwarded for, and this header, we just put anything. You can put anything here. So this is going to be the injection point. All right, so this is how the header is going to look like. And then if that is correct, if we run this, all right, so it comes back, so it's like it's successful. So we can clear this and then come back here, and then now we are trying to do our own injection. All right, so let me use double quotes for the external. All right, so now we assume that the star or whatever is here is what is going to add to the database. So we can now inject our own SQL query. So we can now use our union select one. No, so here this is going to be like, we're going to use time based. Okay, so this is very important. We're going to use time based, so because it's blind, we're not going to see the output, so we're going to use blind. We're going to see how time delay is going to use. So if it delays for the number of seconds that we've introduced, then it means our query is working. So we're going to sleep for, let's say, 3 seconds. All right, so if this is correct, then it should sleep, but it didn't sleep. All right, so it clear and come back, and then it means we don't have one column. We say sleep, another. So now we are trying to introduce 2 columns with the sleep. All right, so still it doesn't work. So let's clear, and then now we go further, and then we sleep. We'll put 3 columns. Still this is not working. All right, so let's see, let's sleep for 4. I think if it doesn't work, I think, all right, so this is still not working. I think we have an issue here. Let's try to troubleshoot. X forwarded for, I think it's supposed to be 3 columns. So since it's not sleeping, it means we may have to actually troubleshoot our query. So the X forwarded for header for curl is it, let's see, let's come here. SQHell. So all right, so Kel, I'm trying to see all the headers we have for Kel options. So it's possible this particular header, this is not how it's supposed to be crafted, but where I'm not getting the full Kel. So let's see, let's use man Kel. All right, so this one should be able to give us more details about the Kel command. So let's search for header. So are we getting somewhere? Yeah, let's use page. Okay, so here we can just go to Google and do a quick search using Kel with headers. So let's see what we can get. So to use Kel with headers, okay, so it's actually tag age, yeah, and the header, yeah, so that was correct. Yeah, so Kel, okay, yeah, so it looked correct. So so what's wrong with our Kel command? Let's see, let's go back. So header, okay, so I presume, so I think this particular asterisk, we can take that off, and because like it's matching for everything, and we try to sleep again. Let's see. All right, so this is still, so let's sleep for let's sleep for another 3 seconds. Okay, still coming back. Let's sleep again. Yeah, so it's a bit tricky here. X forwarded 4. Okay, my bad. I think yeah, so what we had to do, we're on the right track, but we just got a bit sloppy. So we forgot about commenting out the rest of the query. All right, so this last comment that we're not adding, I think that should be the problem. All right, so it's still not, so we go back, and now we add another sleep 3, and now you can see that it's taking time. All right, so it's sleeping for 3, so that's for 9 seconds. all right, before it came back with our output. So our query is now correct. All right, so instead of sleeping for this long, so we'll just use the first sleep and then 1, so 2, and then 3. So they should sleep for 3 seconds. So 1, 2, 3. And it should come back. All right. Okay. So I think we got our query now. Okay. So that should be it. All right. So that's the right query we've got here. And now we can say from, let me expand, from flag where flag like, where flag like percentage. So if this query is correct, it should sleep for 3 seconds. So yeah, sleeping for 3 seconds. That's good. So we clear our screen, come back. So now we can brute force the characters individually. So if we put A, if our flag starts with A, it should sleep for 3 seconds. If it doesn't start with A, it should just come back immediately. So it doesn't start with A, that's why it just started. It just came back immediately. So we go back and then we try a T. See that it's sleeping for 3 seconds. All right, that's good. That's a good sign. And then let's play again and come back. And if we put THM flag, all right, so I think the last flag is flag 2, I guess. So if we put flag 3 here, it won't work. So if we put flag 3, flag 2, you see that it's sleeping for 3 seconds. Good. So we've already gotten part of our flag. So this is how the part of the flag looks like. And then the rest of the 32 characters, you're supposed to do them like that individually. I think they are hexadecimal. So from 1 to 9 and then A to F. So it's X 0 to, I think, yeah, X is 0 to 9. So yeah. All right. So it's gonna be hex. And then we don't have that much time, so this is just how to do it manually. All right, so the next way is to use a SQL map. All right, so I'm going to show how we can use SQL map to do the same thing. Okay, let me just get an error out here and close this. All right, so with SQL map, we specify our URL with tag U, and then where is it, terms and conditions. We come back here, we grab our IP. So this is the URL, and then here also we specify a header. All right, so the header we're gonna specify is x forwarded 4. All right, so that's the header, and then we use dash dash bash and then dash dash dump to dump everything from the database. All right, so if this is correct, it should be able to start. Okay, so I think we have an error here. Let's see, invalid header x forwarded 4. Okay, so this, okay, that's not how the header is supposed to look like. So header is like an object. So we have a name value pair. So this is the name, and then the value, we can just put anything there in our case. All right, so let's see if this one will now work for us. All right, so yeah, so the injection is starting, which is a good sign. And then this is going to take some time to run, so I'm going to pause the video. I'm going to pause the video, and then when the results come back, then we resume. Okay, so the SQL map results are back. It was able to retrieve our flag from the flag table. So here's the flag. So you can see that it got the flag from SQL database 1 flag table, and then in the column for flag we have our flag here. So we have our flag 2. We can copy flag 2 and add it to our flags. So flag 2. So now we have all our flags, but that's not the end of it. I think the last thing I want to show is how to automate it by yourself with a script. All right, so for flag 2, I've actually shown the manual way using the curl. You can use curl command to manually exploit it, and then you can also use SQL map, including the exported header, and then the last one is how to automate it. So for the automation, it's the same process. I think let me go back to my GitHub repo. So here, when you come back here, I have my flag 2. So let's copy flag 2. What's happening here? I'm trying to get the raw version of this. Trying to copy the raw. Flag 2. Okay, let's copy the raw. The raw version of flag 2. Okay. What is happening? Okay, finally we have it copied. Then we can let's get out of here. What do we do? Okay, so flag 2, we're gonna, oh, what did we do? So the other one that was supposed to be flag 3, I think we named it wrongly. Yeah, so that's the problem. All right, so flag 3, so let me just rename. All right, and then now we can save our flag 2. All right, okay, good. So our flag 2 is saved. What we need to do is just to run it. flag2.py, and then also we copy the IP address of our target machine, which is here, and that should do the trick. And you type enter. So it's starting the brute force process, and then we have the first character of the flag, which is T, and you can see that this one is taking some time because it's time based. Okay, so this one takes more time than Boolean based, so this is going to take some time. So I'm just going to pause the video and come back when it's done. Okay, so it's done. The result is back. So for flag 2, we have it here, and then if you check, it took about 3 minutes to do the brute forcing. So we have our flag 2 here, which is the same as what we got from the SQL map. All right, so flag 2, if you play them side by side, you can see this one D15, D15, so the same flags. All right, so we can just now just submit our flags to see if they're actually correct. Make sure that we are not actually getting things that are not gonna pass. So let's say flag 1 is correct. We go to flag 2. Also correct. Our third flag. It's also correct. So the rest of the flags are all correct. Yeah, I guess. So thank you for watching. and I hope to see you again in our next video.